Myself, Jojimol Joseph, here to have a session with you regarding now fifth module, cryptography and cyber security. The module is common web application security vulnerabilities. This vulnerabilities actually means the attacks towards our websites and all. So whenever you develop an application, don't just focus on the performance or stability of the application, but in security. So you have to write secure codes. At least you have to solve some risk while writing this code. Here comes the role of this OWASP, OWASP, Open Web Application Security Project. It's a non-profit foundation that works to improve the security of your software. Actually, they have community-led open source software projects, hundreds of local chapters worldwide, thousands of members leading educational and training conferences. And OWASP is actually the source of developers and technicians to secure our web. And if you are actually interested in ethical hacking, OWASP is a starting point. So this OWASP lists some secure code or top 10 security risk. First, we have to solve that one. At first, we have top 10 security risks there. At first, we can see injection. Injection occurs when an attacker exploits insecure code to insert or inject their own code into a program. Because the program is unable to determine code inserted in this way from its own code, attackers are able to use injection attacks to access secure areas and confidential information as though they are trusted users. Examples of this injection include SQL injection, command injection, CRLF injection, LDAP injection, etc. We can have some remedies for this injection, like application security testing can reveal injection flaws and suggest remediation techniques such as stripping special characters from user input or writing parameterized SQL queries. That's all about this injection. Then next risk is broken authentication. Incorrectly implemented authentication and session management calls can be a huge security risk. When we are writing these codes or sessions, if it is incorrectly authenticated or the implementation of incorrectly authentication codes, it will have huge risk. Because the sessions and authentication calls should be implemented correctly, otherwise it will get attacked. If attackers notice these vulnerabilities, they may be able to easily assume legitimate users' identities. There is also a remedy for that one while we are making code. Multi-factor authentication is one of the mitigate or broken authentication, and implementing DAST and CA scans to detect and remove issues with implementation errors before code is deployed. That's all about that broken authentication. And next comes the sensitive data exposure. Sensitive data exposure. Okay, while we are writing codes, we might be using some APIs which allows developers to connect their applications to third-party services like Google Maps, AWS, Amazon Web Services, etc. They are actually great time servers. However, some APIs rely on insecure data transmission methods. Where attackers can exploit to gain access to usernames, passwords, and other sensitive information. There are some remedies there like data encryption, tokenization, proper key management. Key management. As you know what are how to do key management, public key, and how to protect them, private and public keys. Okay, and disabling response caching can all help reduce the risk of sensitive data exposure. And then comes XML external entities, XXA. Extended XML means extended markup language. XML external entities. This risk occurs when attackers are able to upload or include hostile XML content due to insecure code or integration or dependencies. Nowadays, everyone know that you can log into your Facebook automatically, or when you try to log in, you can use your Facebook credentials or Gmail account to log in some sites. They will ask when you enter into some sites, they will ask for your Gmail or Facebook credentials for entering to that or log into that one. Only thing you need to click on that on allow access, so automatically you enter into the site and will fetch information from your Facebook account, and what happens is they will fetch information from your Facebook accounts or Google accounts on your username, email address, and other status as well while you are entering such sites using your Facebook or Google accounts. So what exactly does this? For example, I will create a fake website and I will get you into my website and make you to log in. I will make you register using your existing Google or Facebook web page. And actually, Facebook is more secure and it will not give complete information or in Facebook interface or infrastructure. Instead, I will just include a system entry, the file or the password.xml or password.entry, etc., so that I can make the Facebook retrieve data on a local information, but it will just pass to the it will not pass it to the exact user, and even the user browser will not notify it that website is reading password data or reading the system information, configuration, etc. That's okay. Then when I see a scan also, you are always using these scans and all SCA scans, and can find risk in third-party components with vulnerabilities and will warn you about them. What you have to do is disabling XML external entity processing also reduce the likelihood of this XML entity. You have to disable that XML external entity processing. That is only the remedy. Then comes broken access control. Broken access control, actually. If authentication and access restriction are not properly implemented, it's easy for attackers to take whatever they want. With broken access control flows, unauthenticated or unauthorized users may have access to sensitive files and systems, or even your privilege settings too. that is broken access control is actually not giving right access to right person. Sometimes if a standard user gains access to admin user account, or if he use if a user account were sometimes not able to perform our activity, and our rights our rights were limited. Okay, configuration errors and insecure access control practices are hard to detect, as automated process cannot always test for them. Then penetration testing can detect missing authentication. Penetration testing. But other methods must be used to determine configuration problems. Weak access controls and issues with credentials management are preventable with secure coding practices, as well as preventive measures like locking down administrative accounts and controls and using multi-factor authentication. All these are the remedies for this broken access control. Locking down and administrative accounts, accounts and controls, or using multi-factor authentication, not single factor